Good morning, everyone. This is Daniel Redmond with Moonblink Communications. Wanted to thank you all for attending today, and good morning. Real excited about the partnership that we launched here beginning of this year with Broadband Antenna Tracking Systems. I believe a very unique product that for some unique applications for mobility and long-distance point-to-point applications. One second here. Okay. So I'll just do a brief introduction of Moonblink, and then I'll be handing over the microphone to Phil Kramer, who's the VP of Sales and Marketing for Broadband Antenna Tracking Systems, also known as BATS. As many of you know, we're a value-added distributor based in Silicon Valley. Moonblink's always out looking for the top tier of equipment manufacturers that are out there, and we really feel like we've found a strong partnership here with BATS. They have a unique product for mobile applications, a lot of government applications we've had some success with, ship to shore, and also mobility. So a product that's a niche product, but it really comes to play for unique applications. So look forward to showing this with folks there at BATS. And what we're going to do here is, if you guys have any questions, feel free to ask them online, and at the end we'll go through and we'll answer the questions together between Phil and I. So with that, Phil, I'll let you go over and take over the mic and take it from here.
Okay. Well, thank you, Daniel, and good morning to everyone out there, and good afternoon to those of us who are in the Eastern Time Zone. As Daniel mentioned, my name's Phil Kramer, and I'm with Broadband Antenna Tracking Systems, or BATS. And today what I'm going to share with you is an innovative, industry-first technology that was developed, and talk with you about the benefits in specific applications and where it can help you be more efficient, as well as present some really good, economic metrics for you. In terms of BATS, we were founded in terms of who we are, we're a private company based in Indianapolis, Indiana. The system was founded, or the technology was developed, and the company was founded by 3 information technology professors and researchers at Purdue University. It was originally, the technology was developed for the U.S. military, and 4 years ago, this company was spun out of the Purdue Research Foundation. So that's who we are. We're a private company, partially owned by Purdue University. Other than myself, there are 13 engineers here, and we're totally focused on one thing, and that is delivering high-capacity broadband communications for mission-critical communications. And we do that with an innovative technology. We provide a proprietary software and hardware platform that automatically locates, locks, and tracks wireless broadband communication access points. How we do that is our innovative technology. We optimize any broadband radio and antenna combination. And our system is integrated with the broadband radio and antenna. And our software creates search patterns and predictive algorithms that allow us to automatically locate your friendly communication access point, wherever it may be, as long as you have near line of sight. Line of sight is best, obviously, for best distance and throughput. So we find the friendly broadband communication access point, locate it, lock on it, and initiate tracking if there's mobility. And we dial into within a 1/4 degree of pinpoint. So we dial in the antenna, aim the antenna, and obviously that means that you can use a higher gain, narrower beam antenna than you would ever imagine probably using in that type of an application before, if there's quite a bit of movement or sway, or you have periodic realignment that takes a long time for to get realigned. We can do all that alignment and initiate tracking in under 1 minute. Our technology supports and enhances any wireless communications system or vendor equipment, so our technology is completely agnostic in that we can be paired with any broadband radio and any antenna. And then after that, the system can be remotely managed via IP. So as long as you can get access to your network, you will be able to, there's really not much management needed, but you can observe, the throughput and so forth that you're getting on a particular link. Key customer benefits. So I've told you a little bit about who we are, a private company focused on engineering and research for broadband communications and what we do and how we do it. Now, what are the real benefits that we offer? Well, first is automatic deployment. And what that means is, obviously, you don't have to have as the point number 5 mentions down there, reduce manpower, time, and skills. When you have automatic deployment, you don't need the skilled technical resources that may be in short supply. And also, if you have remote locations where you're periodically having to move an access point and get it realigned, or you want complete mobility with high throughput broadband communications on a point-to-point or point-to-multipoint configuration. So mobility, quick deploy and tracking. So we do quite a bit in ship-to-ship, ship-to-shore. Gives you improved speed, bandwidth, and time to acquire. We optimize the communication link, so you're going to get better distance and throughput than what your link budget will tell you can get, in that there's a manual fudge factor in there for alignment in the radio manufacturer's alignment, link budget tools. We've never failed to exceed a link calculation that's been run on one of the links that we've set up. We also offer automatic recovery on loss of target. So if you've got multiple friendlies out there and one of the points goes down, it'll automatically reacquire another friendly in the same area. I talked about the reduced manpower, time, and skills. There's remote management, and we're not GPS dependent. This system, we integrate with the radio and read what the radio is putting out, such as signal-to-noise ratio, relative signal strength, as well as with most of the radios that we work with, other unpublished code. And we read that normally via an SNMT or Telnet session. And we just monitor what the radio is seeing or hearing. We don't touch the data layer. We just automatically aim the antenna and radio and antenna based upon where the best communication link is. Where are the target markets? Where have we done the most deployments? Well, a lot in the oil and gas area, both terrestrial as well as offshore. Seismic vessels communicating to each other as they're doing deep sea seismic, as well as ship to platform, ship to ship. A lot in the oil and gas production and exploration area, as well as terrestrial in mining, as well as oil and gas land-based production. Military, we have a number of systems out paired with various radios in the military space with Boeing Integrated Defense Systems, Lockheed Martin, Harris RF. Most of the major prime contractors, our systems are deployed in hostile environments around the globe, as well as first responders. We've done a lot of mobile command units where you'll have a mobile command unit will arrive out on the scene of an emergency. They pop up their mast, and it can really take a long time, even though there's an emergency situation going on, to get a good alignment and communications back to their home base or wherever they're trying to communicate. So we've done a lot of first responder vehicles. Obviously, I talked a bit about the offshore work, so it's commercial shipping, and then also surface mining. There's more and more activity we're getting into, a lot of it overseas in terms of surface mining, where there's a need for quick deploy communications and periodic realignment of those access points. And of course, public safety, it really kind of goes along with the first responders. How our system works is that, as I mentioned, we have the system up here. That's a picture of our system, automatically aiming the antenna and then finding the friendly link. If that link goes down, it'll auto-locate the next closest friendly and reestablish communications. And of course, these units can also be communicating to each other if they weren't pointed at shore. Let's talk a little bit about competing technologies. In other words, why does it make sense in certain instances to deploy our technology? Well, currently in the offshore environment, as well as remote applications, unless you build out, until you build out a wireless network, there's satellite communications. We have done a number of fleets where they're daisy chaining out to sea and using our technology to automatically communicate between ships, and basically they run a virtual private network at sea and use our systems as primary, satellite as backup. Problem with satellite, obviously low bandwidth, there's a lot of latency, it's very expensive as well. Multi-antenna radio combination saturating the area, you have limited distance, where we have links that are 30, 40 miles with appropriate height and high gain narrow beam directional antennas. With cellular technologies, there's obviously limited range, low bandwidth, handoff issues. And then, of course, what normally people have done is they've just manually directed the antennas. Well, that's great as long as there isn't any mobility. But when you've got reduced skill set of people out in the field, or you need to really deploy quickly in an emergency situation, then our system makes good sense. Manually is less precise, and there's service interruptions and the manpower expense associated. We have a number of systems. We can go all the way from our miniaturized AMATS 100, which is a domed antenna tracking system. Inside of that system, you have the controller, you have the radio and the antenna, and that system, that's a 8-inch by 8-inch panel antenna inside of that dome. It's 15 inches by 14.7 inches, weighs less than 19 pounds with a radio in it. So that's used quite a bit in mobile response vehicles. And we have systems such as that for first responders. And these are the components that make it up. And then we have our next system up, which is our larger dome system that we've done quite a bit of for long-distance ship communications. Inside of here, you have the broadband radio, as well as up to a 2-foot panel or grid antenna. And this gives you, maximum distance and throughput with the AMATS 300. There you're looking at, It's basically 28 by 28 is that dome.